finally, I'm gonna continue talking, and now I'm gonna start with my the first talk of the day, and my personal talk. It's a little bit introductory to the talks of the next speakers, and I was very actually pleased to see their talks because they are in the perfect combination with mine. So you will receive I would say a solid product of knowledge today. And this talk is about low resource, high impact modern NLP solutions for under-resourced languages. So we're going to talk today about low resource languages, but why I am going to talk to you and who am I, because I didn't fully say who am I. And I am a data advocate at Toloka. I started as a machine learning engineer and I'm continuing. I really like studying, hard skills, and the knowledge of AI in general very much interests me. There is one problem: I really like to talk and I really like to meet people. So in IT society, it means that you're ending up being a data advocate or dev advocate profession. And here I am, and I'm enjoying it a lot. So over the past 3.5 years, I changed a lot of professions because I was trying to find myself, and I did that. But I managed to have pretty solid experience with crowdsourcing and working about it. So if you're going to be any time surprised or having any questions around it, I am the person to help. And my interests are natural language processing, it's ecom, it's search relevance, evaluation systems, and recommendation systems. So if you're working in the sphere or something, I am especially happy to talk with you about, because I will have something to say. So what are we going to talk about today in my presentation, in my introductory presentation? So I have 3 main blocks that I really would love to share with you. Firstly, we'll start with the main subject of the day. What are we talking about? What is low resource NLP? Because maybe somebody doesn't know it, or somebody wants to see how I taxonomize it for myself. Then I'm going to talk about one of the instruments that you can use in the low resource NLP to get more, to get it more forward, to get it more advanced. And I will try to give you some recommendations if you're developing a crowdsourcing solution, or if you're using a crowdsourcing, which points you should look at to make it high quality and useful. And the last one, I really want to talk about our initiative for low resource NLP development. It's voluntarily, it's about preserving and keeping the languages alive. So finally, without further ado, let's start. So what is low resource NLP? In the world, currently there exist more than 7,000 solved languages. And as you can imagine, and the ones that are covered in the modern AI, it's from 10 to 20. And why it was for me so interesting to actually prepare this talk for my visit here, because in India, as far as I know, there are a huge amount of languages which are being overlooked. There are a lot of dialects, and a lot of them are spoken but not digitalized at all. So even prevailing with English everywhere, which is taking up a hole in the internet, there are a big problem of preserving the culture, of preserving the languages, of keeping up, even because there are a big amount of people who are speaking these languages but can't use any products of the modern AI. So there is a problem. And this problem, yes, with low resource languages, that they are presented in the modern digitalization systems in the World Wide Web. If you look at our chart that we found and we collected, that as you can see, English language, it by 10 times far more presented online than other languages. And these languages on this chart, they are called high resource. And still you can see how vast is the difference. I would say some people would assume that Chinese is also very well presented, but when we're talking about low resource languages, we're talking about the being able to get the solutions, being able to get data, access to data. Chinese internet is separate, so this language is actually even seems underrepresented here. So as you can see, there is this amount of languages. You can't see even the main ones that we're knowing and talking about. And we know that now with large language models, which are being trained on the internet data and being so overpowering all the solutions and everything, we can understand that the problem of data sets and the biases of the amount of data being unbalanced is huge. So there are, of course, some main approaches how to solve this problem of low resource languages to preserve their culture. And low resource, as I repeated, doesn't mean that they are like endangered. It means that they are just not digitalized. And there are three approaches. First one, it's, I would say, like taxonomy can be different. This was built on my own taste. So if there are like natural linguists which are not agreeing with me much, I would really love to discuss you what is your taxonomy. From my perspective, these three approaches, they would start with a rule-based and text augmentation one. This one is based on the expert knowledge. So you have a linguist which can create some certain rules and can find a ways how language is built. And by this, he can build systems to make them more high resource. So here we're in the need of experts, and it's not always possible, you know. Second one is weak supervised and unsupervised learning. Here you don't need linguists, but you need data. It doesn't have to be labeled, like it doesn't, like there are several tasks in natural language processing, it's translation, it's entity recognition, etc., etc. They're required, for example, for building some systems, some labeling. But here you just need a huge chunks of unlabeled data mostly. And transfer learning, the hit of them all, I would say the most perspective from my point, the one that are all the BERTs, BARTs, and GPTs are built on. It is very good. It seems that it requires less amount of experts and less amount of data, but it does need human supervision, because when you're taking a big model learned on some chunks of tests, which can't be cleaned because the amount of text is big, you really need to check what is happening there. So I will begin firstly, it's very introductory talk. I am not giving any big insights in this part, but I just really want to show you, to give your interest, what can be the approaches. So the first one, rule-based, as you can see, it's like, there is a very simple example of the rule. Some languages, they are always, any languages, they have some structure. Like, for example, I'm learning German. I'm studying in Germany now, again. And always the verb, if it's not an Nebensatz, goes on the second place, which absolutely blows my mind, by the way. But this structure helps you to label languages, for example, do entity recognition with this knowledge without any additional data provided. Text augmentation comes from computer vision. Computer vision is very popular in the means that if you need more data, you can take your image, you can rotate it, clip it, make some random changes, maybe add some noise, boom, you have a bigger data set. Same you kind of can do with text. You can do synonym exchanges, you can do simplification of the sentences that you have, you can do some translation, back translation to another languages, back and forth. So there are some ways to create more data, even though it will look kind of alike. The second approach, second block of approaches that I'm talking about is which requires not linguists, which are knowing the structure of the language. It requires more data. It's clustering. Clustering, I guess everybody can assume what it can be about. It's when the data of the similar semantics which are met in the same context, it will cluster with a good representation to the same basically place. So for example, we're talking about cities, Chandigarh and Delhi and Bangalore will end up in the same cluster. There is distance supervision, which requires usually some knowledge bases being somewhere. For example, Wikipedia, which is not that reliable, but still it's a great project. Some dictionaries. You can use this, and there are like some structures, some knowledge, some data, which you can somehow scrape off the internet and use in your solutions. But for that, you need a knowledge base, you know, and here comes the problem of digitalization. And the last one is the cross-lingual projection. It's when you're taking your task in the low resource language, you translate it to high resource, solve the task there, translate it back, boom, you have a solution. Here also the problem, you might need to have a translation system for that. And the last one, it's transfer learning. You have a big model. I mean, not specifically big model, I'm sorry. It's like Twitter was last half a year booming with big models that I'm now using this word everywhere. So you have a model which you trained on the available corpus of the high resource languages. They managed to learn some representation, some embeddings in some spaces, vector spaces. And then with a similar languages, basically better works with the languages with a similar structure, because when they are different, it would work obviously worse. You can do some fine tuning, additionally learn the model on the like 100 to 200 examples. For example, this is the number taken from here, and then you will receive some decent result with your model. For example, it works with Turkish and Uyghur. However, there is a theory, like at least it was proven 3 years ago, which is in AI, it's a decade, because you know how fast everything develops now, that low to medium size, but specifically trained transformers, they are working much better in transfer learning than the big models. However, then we saw like the rise of these models, which everybody knows, ChatGPT. Who doesn't use ChatGPT? So here it like kind of comes the question, maybe they do solve the problem. This is the, I would say we will look, I mean, of course, I read a report of ChatGPT 3, 4, and we'll read about 5 when it comes. And I saw that they're supporting some low resource languages. I was interested. We decided to check it. I wouldn't say that it's like a super expert experiment, but just for fun. We checked firstly ChatGPT, how it works on different languages on high resource. We saw that it wasn't that consistent, but it's pretty obvious considering how imbalanced the internet is. So I believe that with the further training, with the further fine tuning and maybe prompt engineering, and it can be also some, you know, sufficient results. Also for fun, I decided when the ChatGPT, like GPT-4 dropped, I paid for it. I did an account and I checked even that from Russian language, because I am Russian, so my mother tongue is Russian. And this is considered to be the high resource language. And you know what? It started hallucinating on the simple question. Does it mean something? No, it does not. But I was just going to say that there are still in the scientific society, the general theory that specifically trained, specifically supervised, human supervised models in the low resource languages, they work better than these big ones, or these big ones need human supervision, maybe with reinforcement learning with a human feedback, but mostly they just lack the data to train on. So here we have 2 things that we lack. We need a domain expertise, not always the specific like doctor, engineer, university student, something, but at least we need a person who speaks and writes this low resource language, or just speaks at least something. And we need data, and we need data in a good quality. So since I have most of my experience in crowdsourcing, I would suggest you to give one of the solutions how to get data. And of course, it's not the only one instrument that you can use, and it's always the trade-off of ability to use the crowd, fight the crowd, find the money and everything. But one of the approaches to find the low resource languages and give the ability to annotate data can be. Why? Because mainly if you are decompose your tasks enough, you can give for the people who are providing the tasks, crowdsourcing workers, you can give them very simple tasks for which they don't have to learn. For example, just reading or writing, like, or just like, I don't know, giving a voiceover. And it's pretty easy, pretty scalable, not that expensive. And with that, you can preserve your low resource language. For example, what can you do with crowdsourcing? Because it's pretty flexible. You can just collect data, do the sentiment evaluation, because you just need to tell it, is this text good or bad? You can do the user intent determination, find what does he want to do. You can do some named entity recognition or like search relevance. I was talking about search relevance evaluation. It's only one of the ways to give the crowd to take, okay, if I type in jeans and I get the t-shirt, is it relevant or not? It can be transcription of the text, which also helps a lot because people can talk in the same low resource language, but have the different accent, different dialect. As again, I'm using Germany today, for example, not a big country, but my God, their accents, as I know from the Germans, they can't understand each other. I'm in Bavaria, and this is like a complete different word from, for example, Berlin. And also you can do vice versa. So from my perspective, what is important when you're using a crowdsourcing solution? There are 4 blocks that you need to take in the account to receive the quality data. Because the problem is with crowdsourcing in general, that interesting as go and play with the models, from my perspective. But it's sometimes from data-centric approach, it's very valuable. And the second one is you are not sure that the data would be somehow like quality. There will be some quality. Because there are like some random people, they're providing you some data, and then what? Maybe it's bad. So there are some mechanisms and some tips and tricks which you can use to ensure the quality. From our perspective, from my perspective, it's filtering. So you need to really know which crowd you're choosing, how to filter it based on the composition of your assignments, based on the task you're doing. Maybe there is slang, maybe there is something. You need to know region, you need to know culture. Second, it's about training the crowd. It's always here, you usually require the help of one expert. There should be a really, really decomposed tasks because people are learning also on a few short examples. You need to give them a variety of examples. You need to test like balanced classes of examples. You need to test that they really know the language and they really can provide the results. The most important part is the quality control. Of course, there are some basic things that checking fraud in or something, but mainly there are like some mathematical models which allow you to aggregate simple answers in the very actually like from raw data to high level data. For example, if you're working with crowdsourcing, it's very easy to give them an assignment. What do you like more? This or this? Pairwise comparison. Or what do you find a better translation? Left or right? And they will just tell left or right. But there is a Bradley-Terry model which takes up these lefts or rights and aggregates them in an ordered list. So here you can, with some certainty, I'm sorry for this, figure of the speech, you can provide the result without giving them complex tasks. And the last, of course, just gathered it up. You need to have models. It's very good to use some supportive machine learning a little bit. You need to be very sure about anti-fraud. You need to always work with your crowd, look at the solutions, how they're working in the moment online, and get the feedback from them. And of course, you need to give them fair pricing, So well. Okay, so we're getting somewhere. Okay, so I wanted to talk about the initiative for low resource NLP that we're doing in Toloka. It's voluntarily. It's about preserving the languages. And I am really sure that in the crowd there are people that know some languages which are under-resourced in natural language processing. And it's important to preserve it for culture. So we're also a crowdsourcing platform. We have some experience in doing so. And our coverage is around 40 languages plus spoken. The problem is that it's basically still very far from 7,000, So we really care about the cultural preserving of the languages. So we started a researching initiative. We're very welcoming to linguistic experts to get the grants from us and start working on preserving the languages. We are finding the crowd around the world which are speaking these under-resourced languages, and we are developing data sets and natural language solutions, natural language processing solutions with us, with linguists, with this voluntarily work, to maybe also give them some, appearance in the world, to give them appearance on the conferences, and just to, keep them in the modern AI. So not to be the person who is speaking about something that we just started and we don't know how to proceed with it. We already did some certain voluntarily work with that. We did the first when we were on the machine learning translation conference in 2022 on the NLP. We were doing the evaluating quality of machine translation of the 14 African languages, which are low resource, not because not enough people speak them, no, a huge amount of people speaks them in the world, but they absolutely not digitalized. So we were finding the crowd, which in Africa, which was interested in that, which was interested in doing the crowdsourcing work. And we managed to provide some data sets on this workshop. So there are in the resources, there are papers from this workshop. So if you're interested, you can check them out. Also, to show you how in general it works, for example, here is the interface that we use for this initiative. There's one of the ways how you can do crowdsourcing tasks when you're doing the machine translation. Here I'm talking about exactly providing the crowd two options from which you can choose with the translation. It's a good practice and it works very well when the crowd has more simple tasks. And we built this pipeline which you can reuse, for example, somewhere in your solutions, if you're working with crowdsourcing or also preserving low resource languages. I don't want to take up much of your time on this pipeline, especially if you didn't like work with crowdsourcing yet. However, it will be in the slide, so you can look at it, you can like evaluate how it will be useful for your work. And also the second initiative that we did, it was with endangered languages, Yakut languages spoken in the North Siberia. Here we just tried to keep language intact to preserve it, because people speaking it just literally stop speaking it. You know how the languages die. So I am really, really encouraging you to participate in initiatives like this, just because it's really important. So to sum up what I was talking about today, what are we talking about, and we'll proceed. Firstly, low resource NLP still needs attention, even if we have really, really huge progress in a lot of fields. And I've heard a lot of words like, modern NLP is dead. I need to quit my PhD. My God, what I'm doing. No, you still have something to do, you know. The second one of the methods to use here, one not only, but one of the ones that we tried and it works, it's crowdsourcing. And we try to give you some tips how to use it. And finally, we are really committed to support the inclusion of the low resource languages in the modern NLP. So if you want, please come and let's talk about our research together. And I am leaving these references. I'm really thankful that you listened to me today. And I am really willing to receive some questions if there are any, one from you and one from the Zoom, and then we will welcome the next participant. Okay.
Thank you, Evgeniya.
Sure. Okay. I see the. Oh.
For the talk, awesome. This is Prasun from Lab 45 Wipro. So in one of the slides, I saw that Toloka.ai and Meta and in NLP 22, there are low resource languages from Africa, probably a bunch of them, and English was also there. So I was curious, was that a typo or was it misplaced below Chichima, or is it?
You, it wasn't a typo and misplaced. It was, I guess, my bad organization of the slide. So we used here as a translation of the targeted languages to make one of the techniques, the projection. We used translation between English and French. As you can see, French is also here to African languages. And also, I am not sure, but this is my actually point. I know that some languages, they are somehow the versions based on the geographical and political situations. They are versions of other languages with some, for example, I know that Afrikaans is somehow similar to Dutch, if I'm not wrong. So I am not sure, but I think that it somehow also was used maybe for annotators, which were mostly speaking, because usually for annotators, we require, not always, but for this task, we require them to speak high resource language and low resource language. So low resource are the South African, high resource was English and French. Yeah.
Got it. Okay.
Thank you very much for your attentiveness.
Okay, makes sense. Thank you.
Valia.
We don't have questions still in the chat, but we asked to do that.
Okay, so I'm okay. Then we're doing 2 questions from auditory, and we're done. Okay.
Hello, can you hear me? Hey,
Yeah,
hi.
absolutely.
Thanks for the talk, and I'll probably continue the question. So there are different language families, right? Like Asiatic language families, and then there are African language families, which are totally different. So how do you guys do transfer learning over there? Because the language structure, as I understand, is very different. And do you also because these all languages look to me like Congo African languages. Do you also train amongst themselves because all the resources are we are having less resources? So do you do that?
So we managed through the years of our development get actually a very big coverage of crowd in African countries. So somehow we are able to gather data sets of the enough volume to train models originally on them. So we're just having the people speaking these languages. We don't do transfer learning here.
Excuse me. Do you have a family of languages?
Can you repeat what?
For example, Telugu and Kannada.
Yes, absolutely.
So do you? Okay.
So do you, so I thought that's what he asked. So do you get some transfer learning between these two or no?
In this particular task, we were the one gathering data to perform the meta company to do the transfer learning. However, from my perspective as a machine learning engineer in the past, and we are also doing machine learning models in our company on the top of the crowdsourcing, I would say that it would be a perfect and absolutely essential idea to do it, the transfer learning between the same family of the languages, as I was telling. It would be not very smart to do so with languages from the other family, for example, even English or French. So that we weren't doing. Yeah.
Okay, thank you.
Thank you very much. So are there?
We have a questions from Zoom.
Only one, and
two.
We really need to give our next.
Yeah, we have 4 minutes for our next topic, and the first question is: how do you deal with dialects, and are they as separate or in the same language?
We're trying to distinguish with the crowdsourcing by filtering dialects too, and they are not considered the same language.
Okay, and one more question from Mike. How do you handle Pidgin languages like Pidgin language, Creole, and Patois?
Here, I personally can't answer this question. Please tell Mike to contact me in LinkedIn. I will do the personal research on our project on the African languages. I'll return with the answer.
Okay, so Mike, if you hear us, please reach out, Evgeniya.
I think that it will be perfect if I will ask everybody who has more questions, come to me on the break point, because I'm here for 1 hour, 15 minutes, and actually more. So you can always ask me even later. So please, any questions, if you're gonna stay, please come after, because I really wanna welcome our next speaker, who is a little bit tight in the time schedule.
That's true.
I am very sorry, guys, for stopping you with the knowledge flow, because I know that asking questions is funny. Please write them down. Please contact me. I will be very honored. So our next speaker, I hope we have the presentation here.
We just have to stop sharing.
We just have to stop sharing. Okay, so our next speaker is actually, as I remember correctly, and I hope I am not doing the wrong thing, is also from Microsoft. He is Monojit, and he is going to be today so pleasant to make my talk less welcoming, introductory, and broad, and to make a little bit more insight on the low resource languages and give other approaches, more algorithmic ones and less human-centered ones, for the development of low resource NLP. So I hope we can see Valentina will manage to do something to make his sim in Zoom, and he will tell you his warm hellos.
We can hear you. We see your slides, so that's your time.
Okay. Yeah, so first of all, thanks for inviting me to this event. And it's very strange for me and also ironical, because the office where this event is happening, that's where I go every day. But today because of some strange final minute, scheduling issues. I had to travel at this moment. So I'm right now at the airport in a cafe giving this talk. I hope not many people stare at me thinking what I'm doing here. The other problem I have, unfortunately, is I have to rush for my flight at 6:15. So I would love to take questions, but I have a hard stop at around 6:15. Yeah. So with that, let me begin the talk. So thanks first of all to Jenny for setting up the context very well. And in fact, I was very excited to see all the great work Toloka is doing in the area of low resource languages, and it's totally aligned with the work that I have been doing with my colleagues at Microsoft Research India, and more recently I have moved to a team called Microsoft Turing, which works on these large language models, things like GPT-4 plus Bing and stuff like that. The things that I'm going to share are more from what I did with my colleagues from MSR, and I'm still working on them, which are around low resource languages. So how can we scale these large language models for as many languages as we can? And actually, the second last question, which was about transfer. Can we transfer, or how well can we transfer from Niger Congo to, let's say, Indo-Aryan languages, or from Arabic to Korean? So across families or within families. This is exactly the question I'm trying to answer in the talk. But before that, of course, I'm not going to tell you a lot about the situation today. You all know about ChatGPT, GPT-4. They have taken the world by a storm. But one good thing I want to point out is, the fact that this technology at least is kind of available or known to the whole world. When I say available, I don't mean people can use it as much they want, but at least everybody know about it. There is some way to access it to some extent. And this happened very quickly. In a matter of just 5 days, millions of users could access ChatGPT. Now, this is a good sign. This is a very positive sign that technology in some sense is democratizing. But unfortunately, if we look at some other axis, the story is not so rosy. And one is that of language. This is a work we did a couple of years ago. We tried to estimate the amount of resources that's available in various languages of the world. There are 6,000-7,000 languages. And the two kinds of resources that are important, which Jenny also mentioned, one is unlabeled corpus, like running text, and one is labeled data, which requires human supervision. So, of course, labeled data is more expensive to build. Unlabeled data is slightly easier to get for some languages. So, if you plot the world's languages in this, way, you will see that some languages have very large amount of resources and some has nothing. The interesting thing to note is this is a logarithmic scale on both sides. So this language, which has highest amount of resources, is English. And the next set of languages, which include languages like Chinese and Spanish, has one order of magnitude less resources than English. And that's exactly what Evgeniya was mentioning. So even though we call Chinese a high resource language, the gap is still huge from English. However, the gap is even huge if you consider the other languages. So looking at this distribution, we divided the languages into 6 classes. And, there are only 7 languages in class 5, the high resource languages as we call, and there are 2.5 billion speakers of these languages. Whereas, in class 0, where there is absolutely no resource, more than 2,000 languages are there and spoken by 1.2 billion speakers. So in some sense, 88% of the world's languages spoken by 1.2 billion speakers are completely untouched by the benefits of the language technology that we are building today. So that's something to keep in mind. So the technology that we are all very excited about today, that many of you were asking about, transfer, etc., this came around in 2019. So in short, what this technology does is if you feed it a lot of corpus of different languages, so I take English, Hindi, French, Swahili, Kannada, everything separately and train a model, it learns somehow a common representation for all these languages. And after that, if I have, let's say, labeled data, which is difficult to get and for which you need, startups like Toloka or crowdsourcing platforms. For that, you can get this kind of data, let's say sentiment analysis for only one language, let's say English. Now you train it with English. Now, ideally, this should definitely work for English, but quite surprisingly, it starts working for all of these languages. So this has a big promise, right? So the promise is now with only unlabeled data, we can get fairly good accuracy across a large number of languages. No language specific label data is required. However, if you look at it a little more minutely, and many people have done this research, including ourselves. So if you look at tasks and accuracies of across tasks, across languages, there is a huge gap. So in this graph, there are a bunch of tasks that are shown on x-axis, and the accuracies across those tasks for languages from various families. And you see, English has the highest. The plus there is English, so it has the highest accuracy. The data was also in English. English is called the pivot language here because the original data using which the model, label data using which the model was trained, is in English. But for all the other languages, you can see there is a varied amount of accuracy, and some of the languages like these Sino-Tibetan languages, or sometimes these Austronesian languages like Indonesian, Santali, have very low accuracy when you start with English. So we need to do something for this. The solution that we are talking about is not a panacea, but it holds a lot of promise. So what can we do? So that's the question I'm trying to answer here. Now, many of you might say that this is a paper from 2020. I'm talking of technology from 2019. World has changed dramatically since then. Yes, you are right. 3 months, in November came ChatGPT, and more recently in February or March, we announced GPT-4. These are much more powerful models. But even recently, my colleagues in MSR and Microsoft Africa Research Institute had done a benchmarking experiment, again similar to Evgeniya, what she was talking about. So a systematic experiment with GPT 3.5, which is actually ChatGPT, and they showed that it's not better for low resource languages from actually some of the earlier generation models, like let's say Turing, TULR version 6, and so on. So it's not that we are really, we are making a great progress in language technology, but all languages are not moving equally. And in fact, if anything is happening, we are widening the gap between the languages which have and languages which don't. So the three things, the question is then what can we do? And we can take a systematic approach here. And I would say there are three things that we should do. First is even to understand where we stand with respect to each language. So that comes with evaluate. And as I will say, even evaluation is a hard task. The second is, once we have evaluated, we need to ask questions like what affects the transfer? So explain this zero-shot transfer. And if we understand that, if we can explain that, probably we can exploit our understanding to strategize the third step, strategize data collection, and strategize in other ways to help all languages come as close to the high resource languages as possible. So I'll go through all these three items one by one, but most of the time I will spend on evaluate, because the other two kind of follows immediately once you evaluate things properly. To start with, while you can get transfer learning without labeled data in a language, you cannot evaluate for a task without labeled data in a language. So evaluation demands labeled data in all languages. That's one thing to remember. And unfortunately, we don't have that. So this is a graph which shows how much data we have across languages for evaluation of simple tasks like sentiment, or natural language inferencing and so on, it turns out that there are some 60 or so languages where people have collected data out of 6,000, mind you. And even for those 60, out of those 60, it's only like the top 10 languages where you have sufficient number of tasks. For all the other languages, as you can see, there are 1 or 2 tasks. So it's almost like we have evaluated for 15, 16 languages, and we see transfer learning works, and we are claiming that, hey, it works for every language. It's like I have built a medicine which works for human and whale, and I claim it works for all mammals. A doctor will never do that, right? So as language technologists, we should also never say that. So ideally, we should start with a very solid evaluation. So for that, data collection is vital, and all that Evgeniya told before me applies. And there is no shortcut to that. However, what if we could, at least to some extent, predict the accuracy of a trained model in a particular language, given all the setup conditions? I'll come in a moment what do I mean by the setup. And if we can predict, there are, of course, one thing is I have at least some rough estimate of how well this model works in my language. But more than that, I can also use this predictor to understand what affects my cross-lingual transfer accuracy. Again, going back to the question asked in the previous talk. So I can understand that. And the second thing, it also might help me, exploit this understanding. So given a fixed budget of data collection, I might prioritize now in such a way that based on my prediction, I know that I will kind of optimize accuracy in certain languages which are of my interest. So for last 2-3 years, we worked on a project called Litmus, linguistically informed testing of multilingual systems. And we tried to solve this problem. It will be difficult to get into, given the short time, it will be difficult to get into the technical details of how Litmus works. At a high level, I can tell you that it's a regression that we learn. Each language is represented as a feature vector based on certain things that I will show you in a moment. And then you try to predict on new languages. But functionality-wise, this is what it does. You can select, so this is a demo of Litmus, which is available online. You can go and check. The link is here. There's the code also available. You can develop on top of it. Many people have been using it and developing on top of it. So what does Litmus support? To start with, you can specify which model, which pre-trained model or embedding you are interested in working on. Then you can specify what task you are interested in. Then you can specify how much data you have to do the fine-tuning. Fine-tuning requires labeled data. So you might say, oh, I have 1,500 examples in Tamil, and or maybe you can say I have 1,700 examples in Tamil and 1,700 examples in Japanese. So you can select whatever you want. So these are called fine-tuning configurations. So you give these configurations. Then you tell it what target languages you are interested in. So these are languages where you want to know the accuracy. So let's say I'm interested in knowing about the accuracy in English, French, German, Tamil, etc. So then you run the model and it gives you something like this. It will tell you, okay, for French, you will get this much accuracy, for German, this much. And it will also tell you the mean absolute error of this prediction is 0.4%. So for French, if it is predicting 92%, then it should not be, it should be between 91.6 and 92.4, but not the range should not be more than that. So it's that way, it's fairly good, right? If you can make predictions within 0.4%. Then you can do a next thing, which is even more useful. So there are these budget settings. You can say that, okay, now I can collect more examples, more training data. So it asks which languages can you collect training examples in. So I can say, okay, these are the languages. Then it asks how much additional examples can you collect. Okay, 8,000 additional examples. I can give it more detailed constraints like, language specific budgets, etc., etc. Then I can also tell it what I want to optimize. So I might want to optimize the average accuracy across all these languages, or I might want to optimize the average, maximize the average, subjected to certain constraint that no language should have less than this much accuracy. So I can do all sorts of sophisticated, planning here. And then when I run this system, it tells you, how much data you should collect in various languages. And then it also tells you if you do this collection, you will get 5.77% higher accuracy, than a baseline accuracy that you started with. And it also says that if you were randomly dividing your data collection, so you are interested in these 6 languages. So maybe you want to collect, 8,000 examples. So 8,000 by 6 in each, so equal amount. So that's a very obvious thing to think about. But it says if you do that, you won't get very good. I mean, you can do even better, if you use this method. Now, one point I want to note here, though, is in this 0.4% absolute error, you achieve only when there are some, tasks for which the target language has some data on which you have made some observation. May not be for this task, but some task. But what if you have never observed anything about the target language? So let's say Santhali, there is no data set anywhere. And I want to ask this question. That's possible too, but there the error bounds are a little higher, around 5 to 6%. But probably given that the whole gamut of accuracy could be as big as 20% to 100%, 5% is not that bad a gap. So now the question is how all this happens, right? And as I said, it's a regression. But what are the features that we use in this regression? There were many features that we tried. I will only tell you the things which turned out to be influential. So one of the very important features that we observed is subword overlap. So subword overlap means, so what happens in these neural systems is when you take the corpus in a language, you break each word into subwords. This is important because you can't represent all words in all the languages of the world in a single model, because the vocabulary will just explode. So you break it down to a smaller set. So typically your vocabulary is, let's say, 50,000 subwords. Within that, you want to represent all the languages of the world, or maybe 100,000 maximum, something like that. So if I have a pivot language, let's say English, and a target language where I want to estimate the accuracy, let's say Hindi, I want to measure, given an English corpus and a Hindi corpus, what is the typical overlap of the subwords? How many subwords are common? As you would guess, between English and Hindi, it will be very, very small because they use different scripts. So, but between English and German, it will be very high. The next set of features are around typological relatedness. So this goes back to the family question. So languages belonging to same family will have high subword overlap, but also will have things like they will have similar grammar, they will have similar sounds. Sometimes they will be also geographically closer. So these are some of the features that we model, and this becomes important. So how much similar the pivot and the target are to each other. Third is, of course, pre-training data size. When the original model was trained, how much corpus size was used for that and for the target language. And the last part is that of tokenizer quality. This is a slightly technical point. So I told you that we tokenize words into subwords. We break it down. So the algorithm that does it is a statistical algorithm. It really doesn't use any linguistic information. So what happens is this algorithm does very well for languages where there are a lot of words to learn from. Whereas for languages where there are little data, the quality of the tokenizer is also bad. So it will tokenize it at wrong points, or it will tokenize it at every letter or something like that. So you don't get meaningful subwords. So with these 4 or 5 features in mind, let me present you the bird's eye view of what we learned when we did all those experiments. So what do we see? So this is called a Shapley value chart. What it shows is here are the features in the columns, and in the rows are the tasks. And it shows for which task, which feature is important for prediction. Higher the value, the stronger the predictivity. Although don't don't confuse it with higher the value, it means, it's a positive correlation. It might be a negative correlation. It says how strong is the correlation, how strong is the influence. So if you look at this chart, the most important quality that comes out is the tokenizer. Like I was telling you in the previous, just before the slide, right, about tokenizer quality. So tokenizer seems to be very, very crucial. The second one is geographical distance between pivot and target. So what it means is if you are training with English, you will get very good transfer to German, because German is just next to, pretty close to English speaking country, or very good in French, but very bad in Hindi, very bad in Swahili, very bad in maybe Arabic. So the distance, smaller the distance, the better the transfer. Similarly, subword overlap has a strong impact. And again, subword overlap also has to do with language family. And sometimes, two languages which are distant might also have good subword overlap. Example is Swahili and English, because somebody asked a question about pidgin, right? So there is a lot of borrowing between languages often. So languages like Afrikaans and Swahili, they have borrowed a lot from Dutch and English and all. So that's why sometimes if you train with Dutch or English, you do get reasonable result in Swahili or Afrikaans, but you may not get that good result for Zulu, for instance, which have not borrowed that heavily on English. Yeah, so these are the important things. Now, of course, and pre-training size also matters. Now, based on this understanding, what can we do? One thing is we have to do better tokenizers for low resource languages. Now, for that, one thing I propose is instead of going with purely statistical tokenizers, which always give you better result for high resource languages and poorer results for low resource languages, can you do more, tokenizers which are more kind of fair across languages? And maybe for low resource languages, you can use linguistic rules to get better tokenizers. Then the second point is if I have a target in mind that I want to improve my performance in, let's say, Zulu, I want to choose a language as pivot, which is closer to Zulu. If I want to improve the performance in Marathi, I probably should pump in more resource in Hindi. Of course, in Marathi also, but if I can't kind of push more resource in Marathi, at least I should push more resource in Hindi. So how can you choose the pivot better? And finally, with these new ChatGPT kind of models, there is this notion of reinforcement learning with human feedback, RLHF. And there also probably we can improve low resource languages by doing RLHF with them. Now, this is a area which needs to be explored, because this came very recently and not many people have done experiments with them. But maybe there is something promising there. Now, once we understand all this, what can be a global strategy, right? I mean, there are 6,000 languages. I can't really work one language at a time. I mean, of course I can, but by that time it will be too late, because one language is dying every 2 weeks. That's the rate of language extinction. By the turn of the century, 50% of the world's languages will be gone. So we need to do something quickly. And if we can come up with a global strategy to kind of support all the languages or as many languages as possible, that will be great. So given all this that we know about transfer learning, can we chalk out a global strategy? And here are some ideas. One is, like I said, geographical distance matters a lot. And geographical distance also indirectly affects syntactic distance and subword overlap and those kind of things. So if we can cover languages by geography and pump in resources in each geography, that is very, very useful. So recently we did a study where we wanted to see how much ready we are for the next pandemic in terms of making a chatbot. So when COVID happened, a lot of people wanted to build chatbot for information dissemination, symptom checking, etc., across the languages of the world. But it was very hard to make chatbots for most of the languages. Rule-based chatbots people could make, but beyond that, it was very hard. So we did a study to show that, there are big gaps across the world. If you look at where we can't do anything. So red ones are, places where we can't do much. So you can see whole of South Asia, there are lots of languages where we can't do anything. And English we can do, but how many people in India, for instance, understand English? Maybe 10% of the population max. So for the remaining 90%, they don't know English. Do they know Hindi, which is also a relatively high resource language? Not maybe 50%. What about the remaining 50%? Not English, no Hindi. So what language do you support? So that's why India is red, right? Similarly, this is the Niger, Congo, and Bantu languages. So this whole region is red. Eastern Africa is red. You have parts of South America is red. This part is green, by the way, because a lot of people here speak Arabic, French, or English. So they are kind of covered. So the situation geographic wise is pretty pathetic, and we can definitely do better if we systematically and strategically try to collect data. The second thing is we want to cover typology. This goes back again to the family question. So we should identify families where we don't have enough data, language families, and collect data for those. Third is one interesting thing that we can do is transliteration. So if you think of it, all the Indian languages are written in different scripts, but they share a lot of words. So a lot of Hindi words, Hindi has a lot of subword overlap with Bengali, but Bengali and Hindi are written in different scripts, so the model will never understand it. So if you transliterate Bengali to Hindi script or Hindi to Bengali script or some common script to both of them, let's say Roman script, then the subword overlap will be more apparent. So this kind of things people have tried and they help. Third thing you can also do is make region-specific LLMs. So let's say AfriBird is a bird-like model for Africa, or IndieBird or Mural. These are models for specifically for Indian languages, and they are much smaller models and actually have much better performance for these languages. So that's another strategy we should go for. And if you think of it from the litmus studies, what we have learned is while label training data is very expensive, so has to be strategically chosen for languages. Unlabeled data and test data can also be strategically chosen. If I know the performance of a model, let's say in Telugu, it might be easier to predict, or I can probably predict with more confidence its accuracy in Kannada, but it will be much more difficult to extrapolate the Kannada accuracy from, let's say, Hindi accuracy, and even more difficult to extrapolate it from Arabic accuracy. So even there, we can strategize the data collection. The last point I want to mention in the strategy bit is that, today, when we measure accuracy across languages and we have this bunch of models, we have a table like this. Now, the question is, how do you choose a model? There are many models. You get all these accuracies across languages. Some model does better in some language, some model does better in another language. How do you choose? This is a very difficult, actually philosophical question. And what most people do is go with the average. And if you do that, in this case, you would have chosen this model called XLMR, which has the highest average. But actually, average is a very bad metric because it is heavily skewed by the highest value and the lowest value. So in fact, these problems have been studied in economics a lot under this theory of, social choice theory or the principles of distributive justice. I don't have time to get into the theory, but I will tell you the idea. The idea is, instead of average, if you look at the model which gives you the maximum value for the minimum accuracy. So if you see for XLMR, the minimum accuracy is 15.9 for Japanese. However, other models do much better in Japanese. Whereas if you look at this other model, MMT, and consider the minimum accuracy across languages for this, you get 43.1, which is much better than all others. So this method, which is called the Rawlsian choice, it asks you to choose MMT over XLMR. And you see, in terms of average, you hardly lose anything. So, and if you continuously do this in your research, that you only keep the model which is the best Rawlsian choice or a Prioriterian choice instead of the best average, over time, it will imply that you are making the minimum higher and higher and higher. So it will definitely kind of ensure a fairness across languages. So this was one of the proposal we made in a LLM 2021 paper. Although, unfortunately, I mean, people do talk about these things, but leaderboards still, mostly look at average. Although other people are talking about other metrics on leaderboards these days a lot more. The last one thought I want to leave you with is the NLP or language technology that we are looking at today is what I call task-centric NLP. Essentially, what happens is I have a task, I have a data set for the task, and I measure accuracy and I want to make it better. But can we think of NLP as a utility-centric, technology development? What I mean by utility-centric is instead of starting with tasks like this, you want to say how the technology can help user communities. So if I make a new technology, what difference it makes in the socio-economic indices of a particular community? If it moves the needle there, that's a much better technology. I don't care if it, what's its accuracy is for a particular task and or not. And when you change the problem statement like this, everything changes. Everything changes. So then you look at language technology as an interaction between user and community and technology. And when you start measuring what is important, you would see a rule-based system can be much more useful than an LLM, in terms of those metrics. So we did an entire project we have an entire project called Ellora about it, where we are trying to enable low resource language communities by working with them. I had a couple of slides. I don't have time to cover them, but there will be my colleagues, Kalika and Sunena, and also Harshita and Kabir, who are research fellows. All of them are from Microsoft Research India. So some of them might be there already now, I don't know, but they have promised me that they will be there during the networking session, and Kabir will be there in person. Others will be on Zoom. So please ask them more about Ellora or about Litmus and everything I talked about. Thank you. And I do have time for a couple of questions, I guess.
Thank you very much, Monojit. Let's do one question from audience, and then if you will have time, one question from Zoom, and you will run to your flight, and I hope not miss it and enjoy it. Okay, guys, who I will catch next? We found the, oh my God, you're faster than I think. Okay.
Thank you for the talk, Monojit. It was great. I have one question. So in these characterizations regarding the tokenizer and the relevant features, right? Was it agnostic to the phonetic nature of the task or the semantic nature of the task? Was it like across them, or did you guys classify the tasks and then look at the features?
No, great question, actually. So we did look at, so some of the tasks are more semantic in nature, some are more syntactic in nature. And we expected to see patterns there, like what is more important and what isn't. But we did not see very strong patterns, actually. So the patterns that I showed were the ones which were most robust. If you dig deeper per task, you will see some other patterns also, but we are not very sure about their robustness. And the reason is sometimes these all also depend a lot on data sets. If you think of it, we are measuring the accuracy on only 1 or 2 data sets for that task. And based on that, we are making these comments. So that's why, that's a very good question. And there are some signals that maybe, for syntactic tasks, syntactic distance is more important and so on. But these are very weak. These signals are right now weak.
Okay, and if I can just follow up, you mentioned a point regarding Bengali and Hindi having common words and the difficulty in transliteration. So my comment, I just want to make a comment that most of these scripts are phonetic in nature, right? So that shouldn't be a real issue. So I'm failing to understand the problem here. Thank you.
So that's exactly what I said. So in Bengali and Hindi, so Hindi is written using Devanagari. Devanagari Unicode characters are completely different from Hindi Unicode characters. Now your LLM will only look at your Unicode string. It doesn't understand phonetics, right? So what you can do is you can map the Hindi ka and Bengali ka to the same phoneme. Let's say same symbol, let's say K. Similarly, Hindi A and Bengali are to the same phoneme, let's say A. And if you do that, so that process is called transliteration. And that's possible because of the phonetic nature you set. You get very good results. So you are getting the right intuition.
Could you please tell us, do you have a time for one more question or you have to run?
I do, yeah.
Okay, perfect. As I see nothing in Zoom, auditory, does somebody have any more questions?
We have.
Oh my God. Oh, wow. I'm sorry you have an admirer here, Monojit.
Sorry, I have another question if that's okay. Earlier you said that evaluation is difficult for these transfer learning models because we don't have enough label data in the target languages, right? So why can't you transfer the data back into the pivot language and then evaluate there? Like then you can probably look at the transformation for like two-sided accuracy. Like you'll have two different transformers and you need to balance that accuracy. Why is that not something that's interesting?
Yeah.
Thank you.
So how do you do that, right? You are you saying you translate, right?
Yeah. So you have a transformer that has like that can take you from the pivot to target language. Then you do the task,
right?
And then you can take it back, right? Like
I don't get it. How do you take it back? Because these are not translators, right?
No,
these are,
like so the translation is a task that's well studied. So you don't need like a universal pre-trained model.
So let's see.
Back.
I want to evaluate for Santhali. So I don't have any Santhali data. What are you suggesting?
So let's say that you said that evaluation, the problem is basically you have you don't have labels for the task accuracy, right? Is that
so, so the correct thing is, I mean, what I mean is, so I can't evaluate in Santhali. I might be able to train a Santhali sentiment analyzer using transfer from English. But I cannot test it for its accuracy in Santhali as long as I don't have any sentiment data in Santhali and annotated by Santhali speakers.
But the same tasks you have evaluated it on English, right? And you would know what the answer for that is in English.
Right.
So,
but English accuracy is high, I already know. English accuracy doesn't help me estimate Santhali accuracy.
Maybe I'm phrasing this wrong. So I'm saying like, you don't need to train, you don't need like all the tasks to be trained. You just need like a certain, you need basically translation task ensure that your sentiment analysis is accurate, right?
Yeah. So I understood your question. So you are talking of something called translate test. That's actually something which people try. In fact, the mega benchmark work that I talked about was that, right? So if you have Santhali data, I mean, let's say if you have English sentiment data, you translate it into Santhali and now give it to the model and see the accuracy. You could do the reverse also. Take the Santhali annotated data, don't train even a model for Santhali, translate it to English and run the English model. So people do all these combinations. Now, there are two major problems with these approaches. The first problem is all tasks are not translatable. Sentiment is a translatable task to some extent, but let's say parts of speech tagging is not a translatable task. And the other problem is translation engines don't work for low resource languages. You don't have translation engines for them, which are good enough. So even they don't give you good estimates.
So even the basic tasks, there's a problem.
Yeah. So you can apply this method for French and English, for Spanish and English. But why should we try that? Because we already, have good models for French. I mean, have data sets for French and Spanish. But we don't have data for, let's say, Zulu. We don't have data for Konkani. Now, there, the translators are also pretty bad. You can't rely on them.
Okay, thank you.
Okay, So I will maybe rush to my flight now.
Okay, thank you
Bye.
so much for your talk, and have a nice flight. That's the main thing, and thank you very much once again.
Thank you.
And
have a nice flight.
okay, I will welcome finally. Thank you for your patience, Prasenjit. You, this kind man exchanged places with me because I realized it would be nicer to give a talk in this flow. So I am thank you for that. And I am also thinking that today, I guess all of the questions which were asked for in my talk will be answered in the consecutive speakers' talks. So today, Prasenjit is talking about exactly can we feed one big model for all the tasks, or do we need task-specific models, transformers as I get, for like language and specific, domain-specific tasks? So you're very welcome. The floor is yours. Please proceed.
Thank you, Evgeniya. Yeah, good afternoon, everyone. I think there's a difficult task ahead of me for a couple of reasons. So one are these two great talks that Evgeniya and Monojit gave. The second is I'm heavily jet lagged. So if I look a little sleepy, please excuse me. And the third thing is that I'm standing between you and the coffee. So I'll try to make the best use as I can. So this is a topic, we discuss a lot at our company because we work in the field of education. We are an edtech company. And something here, the purpose of this talk is not to kind of criticize or say, this particular type of model is better than this, or, argue with the numbers that, okay, this model gives better number than that. I mean, some of the numbers and data I've used here are more for illustrative purposes, just to provoke a discussion, right? But not really, to really delve too much into it, because as you know, right, in these days of LLM, new data, new models come out in days, right? You get new benchmarks in days rather than months or years that would have been earlier been the case. Okay. Now maybe I'll just use this. Okay. Yeah, just a little bit about who we are. We are Merlyn Mind. We are an edtech company who are in the business of creating workflow automations for classrooms. In fact, we are the first company to have introduced voice assistant for automating workflows for teachers in the classroom. And so just quickly, let me show you what we do.
Teaching isn't a job for me, it's a calling. But what it means to teach keeps changing, just like the world keeps changing. Technology is a huge part of what I do now, and that isn't always easy.
Hey Merlyn, pair my laptop.
Merlyn is the perfect assistant. Being able to control the technology with just the sound of my voice is magical.
Hey Merlyn, open day one presentation.
The less that stands between me and my students, the clearer our connection can be. And that's freedom for me, freedom to teach.
Okay, so you get an idea what we do. And for our first generation of products, we built something, what we call an Edge AI appliance, right? And our natural progression of this from a voice assistant is to look at how we can use natural language in more and more automations in the classroom. So coming back to the topic at hand, right? And the distinction here I'm making when I say generic models are really the state-of-the-art models like GPT-4, ChatGPT, and so on, which have been trained on a generic corpus, right? Of course, you can give it has instruction following capability and so on, but there's some characteristics of these models that I'm calling out here just to distinguish what I would mean by a domain-specific model, is that they have, there are huge number of parameters, right? And for various reasons, right, these models have been have such an architecture of huge number of parameters. They require massive infrastructure, and I've highlighted few of these words because these become very important when you talk about domain-specific models, right? And they're mostly closed. I mean, you know a little bit about it, but they're not really the open architecture models that exist. And they have been trained on a very large corpus of generic data, and all of these access that you have is through an API. So you don't really get to see what this model is actually consuming. But having said that, not everyone needs the kind of control and accuracy that I'll be talking about for a domain-specific model. For example, these models are pretty good, and they have revolutionized some of the workflows, in especially things that are more generic workflows that have more generic characteristics. For example, informational chatbots for support, for going through a corpus and so on. Copywriting, essay writing, sales and marketing workflows, code is a big one, right? And image captioning and so on. So these workflows by very nature are not data sensitive or accuracy in the sense of accuracy critical, because in the sense you have a human in the loop, right? It's not like that if there was even one mistake that it would kind of really cause a big harm, right? Which would typically be the case when you're talking about finance and healthcare and so on, right? So there is a whole set of workflows these generic models are already enabling and have revolutionized this, some of these industries. But then they also have some of this characteristic which may be very important for some of these industries where I'm talking about domain-specific models, right? Could be very important. For example, energy consumption is a big thing, right? Because if you see GPT-3, just for its run of training, it has consumed almost like 50 to 60 times of what an average American consumes, right, in a year, right? And these are huge numbers, and I'm talking only about the training part of it. There is the whole inference part of it, which is an ongoing. It's typically, I think, about 1.56 or 1.6 gram carbon equivalent, right, for each inference for this kind of models. So right now, I think we are in a phase where we are, these models are showing the possibility of, the art of possible. But I think it's going to become very important future of how you have, the total cost, right, of these in terms of energy, operation, all of these, right, on an ongoing basis. And for example, in education, which is an extremely price sensitive industry, for us, it's very important to be able to say that, that nobody will pay us money just because of the fact that, oh yeah, you have a great language model. We are very cost conscious industry. So we have to be very careful of the energy and hence the cost footprint of whatever we build. The second is agility, right? And the reason this is important is that these models, if you ask ChatGPT or any of these, right, who is the whatever, a very current information, will say as of like whatever that 2021 when I've been trained, right, and so on, right? The problem is that some industries, for example, in education or healthcare or finance, you cannot afford that, because when information change in those industries, the whole cost of anything, right, the cost and implication of anything that happens changes. If I use the information from 6 months, even 6 months ago, right, when a model may have been trained, a typical run of this could be 6 to 8 months, right? That information was used, right? It can lead to huge loss for financial loss, or even a healthcare loss for some of the people, right? So here agility, and right now you'd see sometimes some amount of patchy fine tuning and stuff is being done, but I think that's not really where at least we believe this is not where it will finally land up. The accuracy, right? And it's natural, right? Hallucination is natural. It's something that we all in the industry, we all are trying to solve. But when you train a model on such a huge generic corpus, it is very natural for it to make unexpected connections. And for some cases, right? For example, when we are talking about copywriting, essay writing, marketing material, you want creativity. Where does the creativity come from? From the fact that it makes these unseen connections, right? The whole power of serendipity is essential. But for some other industries, for example, education, healthcare, finance, you don't want to make those unnecessary connections because it can have huge consequences, right? If for example, you must have seen this example, right, where ChatGPT was asked a dietary question and it gave a completely hallucinated reference also, right, of medical text from which it said it apparently pulled, right? So these can have very serious consequences in some industries. So we have to be careful about that. And of course the context, but that's in general, right, for any of these models, right? So and this becomes even more stark when you look at as these three industries, especially I've been talking about, right, education, healthcare, and finance, is that industry regulations are paramount. In education, there's very strict laws governing what you can do with children data, with what kind of data you can collect, where does it go, how are these monitored, the provenance of the data, the provenance of the model, all of that is extremely regulated. And same in healthcare industry, same in finance industry. So in these kind of situations, you cannot expect a generic model having trained on a huge, common crawl, whatever you may say, right, is something that would be very useful for this purpose, right? Data and privacy, again, a very important question. Where does this data go? What has been, where is and you already see the European Union, already coming down heavily on some of the companies saying that what data has been used, have you followed GDPR regulations and so on, right? So that's another area which is going to be very, very critical for some of these industries, right? Governance, right? In finance, especially, right? A model has to go through audit. It has to go through a lot of different checks before a model is put out, right? With provenance of the data, the provenance of the model, who checked it? Was this a third party, right? All of that. These require a completely new architecture, a completely new mechanism by which some of these can be integrated into the workflow. And the last one is the hope that when you train on domain-specific data, and this is something we are already observing, at least in our case, right, when we have trained on education-specific data, is that it makes much lesser amount of hallucinations as compared to when we use GPT-4, right, or ChatGPT. So, and the other fact is this, right, that do we really need, trillion parameter and hundreds of billion parameter models, right? I mean, that's the first big question. And it has already been shown, in the Chinchilla paper, right, that if you have a fixed flops budget, right, and you are able to train a model, you do not, and you get almost the same performance with less number of parameters, but having trained on much more number of tokens, right? That's really the key. So it's not that having a large model where, the other problem with having a very large model is that you are not cost effective. I may be asking for a very simple answer to a question where you have activated all these different nodes to get me an answer where most of them are not even useless. The multiplication and accumulation that you're doing is actually of no use. So we have to start to think about all these aspects, right, of for the purpose I am, and the point Monojit was also making, right, that for that particular purpose that I have, what is the most useful model, right, that I should use, right? And hence the question that I was asking is that, does one size fit all, right? If I have a trillion parameter model, is that all? Is it done, right? So that's really the thing, right? And you see with this Chinchilla scaling laws, right, that you have to increase the number of tokens that is trained on as much, almost equal to the number of parameters that you increase on, right? And typically it's about 20 times of that. So these are things, right, we should keep in mind when we think about that, the choice that we are trying to make in terms of this huge model versus some things which are, and you see many of them, right? I mean, the Alpaca, the stable LM model, the Databricks, Dolly, right? All these models, right? Typically in this 10 to 60 billion parameter model, and they're showing some promise. And of course, the job is not all done, but something that we need to think about. And of course, this comes right from the person who built the best, I mean, at least the company that built the best model out there, right? Is that the age of giant models are perhaps over, and there may be a reason behind him saying that. But we already see some of this, right? Some of why it makes sense, right? As I was saying, right? Some of these models, right? I mean, the whole Llama family of models and so on, right? I mean, in this kind of tens of billions of parameters, you already see some very good results, right? And sometimes if they're not good, they may be good enough for us, right? So there's the whole cost equation that we need to worry about. There's the whole liability equation we need to worry about, that if I made a mistake and said that, oh, I didn't know what my model did, I have no clue of what my model did because I have no clue on what data it was trained on, you are going to be in serious trouble, as opposed to having something that is maybe slightly lower in accuracy, but to be able to say that, okay, this is how or where it goes wrong, right? And yeah, so the question here is that maybe the whole thing, right, as you see, the model architecture is more or less kind of getting into some steady state. I think the focus is back on data, right? And hence, companies like Toloka and others, right, it's a great resource, right, for some of these, whether you want to do RLHF, you want to do supervised fine tuning, all of that, right? Perhaps some of that is coming back to data because the model architectures are more of kind of stabilizing now. So the example, this one example is this Bloomberg GPT you guys must have already seen, right? It's the 50 billion parameter model, right? And you see that it's doing, of course, better than any of those other much larger models, right? Because it has been trained for financial tasks, so it does much better than them. But also for generic tasks, right? You see that it's doing reasonably good, right? And that's what I meant when the statement I made earlier, that perhaps it's good enough, right, for some of the generic ones, but for the specialized ones, of course, you have trained it on a particular data set, on that particular domain, right, on that particular instruction tuning for that particular domain, right? It's performing much better, right? And I'm using this example just to show that there seems to be some promise of that, right? People are already seeing some of those benefits, and something that we need to go deeper into. And then, of course, the other one is the Chat Doctor, right? Which is just a small 7 billion parameter Llama model, right? Which has been trained on around 200,000 labeled doctor-patient conversations. And you see, it's significantly better than ChatGPT. And again, the good thing here is that at least you know what you have trained it on, right? As opposed to ChatGPT, because where you don't know what you have trained this whole thing on. But again, when you come to medical domain, financial domain, we have to be very, very careful, because the lot more work is needed, because these are domains where it's about human lives or it's about our money, right? Which are both very, very, people are sensitive about. So these need more investigation, but I'm using this as two examples at least have, in the published paper domain. And in the education industry for us, right, something that we worry about are basically the laws, rules, and regulations. And we have had a great experience understanding this whole industry, because when we introduced voice assistant in the classroom, people asked us, oh, Alexa is there, Google Assistant is there, why are you building a voice assistant for the classroom? And then, what people realize is that you cannot introduce Alexa or Google Assistant in the classroom, because it's collecting data for which you don't know where it is going, right? And there's huge lot of compliance restrictions on how you can use voice in the classroom. And we went through the journey to exactly understand that it's not just so easy, right? That, for example, on the voice assistant days, right? That having said, oh, you can introduce Alexa in the classroom. No, there's no Alexa in the classroom anywhere in the world, at least, and precisely because of the regulations, right? And hence, to use LLM in education, it's not just about picking up GPT-4 or ChatGPT or BARD or anything, right? To just introduce it in this industry, because it will not work, because it's simply because there are huge number of regulations and oversights that are there in this industry for for you to be able to use any of these, right? And hence, and it's a huge variation of users. It's not like a particular industry that you have like people who have already graduated and then they are working, right? You would find in a doctor's, someone with a doctor or an investor and so on. But here we are talking about somebody from grade kindergarten to high school, right? A huge, breadth of, users, right? Whom we need to cater to. Privacy and transparency and governance is a big concern in this industry, because when we go and talk to the teachers or the decision makers, the first thing is that, what are you doing with the data? Where is it going? If you are saying that you have a model, right? How was that model built? We need to know what was exactly done to build this model, right? So the governance aspect is going to be huge, because we have stakeholders who would not sign off on anything until they are sure that it is not toxic to the students. And but what the view we have is that you have this other extreme where people are saying that, oh, stop ChatGPT use for kids and this one, right? No, we can't do that, because there are huge benefits of this, right? The generative AI is going to bring massive transformation to industries, and we have to look at it in perspective. And for education, we believe that it's not about stopping these tools, but it's about how to use these tools responsibly, how to ensure that we do not harm kids by using these models in a wrong way, or not use training them responsibly. That's perhaps is more important than the fact that oh, don't allow it to use at all. I mean, this is the calculator era, right? When calculator came, people said, oh, calculator, everyone's math skills are going to go down the drain, and nothing of that sort happened, right? So we have to be careful, right, of this fact, right? So finally, generic models, right? I mean, they have their own areas and use cases, right? That they do very well on. They are, of course, expensive to train, expensive to the inference cost could be much higher, because you definitely have a larger footprint of those models and so on, right? And what we need to think about is the fact that the smaller models, right, they could be much more useful when you are talking about domain specificity, right? When you're talking about cost implications, right, of industries which are more sensitive to cost, right? In industries where you need open source models, you need open source, proper transparency, provenance, all of that, right? Where just hiding a model behind an API won't do, right? So in all these cases, we should seriously think about how the whole, the open source community that is putting out some of these models, right, in smaller size and much more, capable, right, having trained on a much larger, and you can see, right, these days, 10 billion parameter models are being trained on 1.6 trillion tokens, right? You see that already it is moving towards the fact of what Chinchilla paper had originally predicted, right? That you get better performance, you will get better performance by having a significant larger number of tokens, right? And if you think about training a huge model with that equivalent token, simply that information doesn't exist in this world, right? Think of a 10 trillion parameter model, you would need about 200 to 300 trillion tokens, right? I mean, that amount of information doesn't even exist in text, right? So So hence, the choice of whether you can, we should use use a generic, these large models which are more closed versus an open, more domain specific models is a choice, something that we should make very consciously. I'm not saying that one is better than the other. For us, at least our view is that these will coexist in, it's almost like, you have a Ferrari and you have a Toyota, right? And they serve totally different purposes and totally different segments of the market. But we have to be very consciously, we should very consciously decide on the fact that which one we should use and take very informed decisions. So in conclusion, we believe that one size doesn't fit all. Thank you. Questions?
Yes. Okay. Thank you very much. I feel very strange saying it in microphone right to your face, but to make it more explicit, thank you very much. Guys, questions, please.
So this was good. And one of the things that stood out was you talked about customer support. So are there examples that are working in customer support area? I believe that's more trainable because you have existing data. Language should not be a problem. So I see that as a low-hanging fruit. So just wanted to check.
Yeah, no, absolutely. Customer support is something I think is one of the, I would say, the hottest area, right? I mean, it had been, in the chatbot kind of domain, but with LLMs, it's becoming much more prominent. But one thing, right, at least we are looking at when we are looking at our customer support for education, right, is what are called these retrieval augmented models, right? The good thing about these retrieval augmented models is that if I give it a corpus, right, of text, it's going to pull it out from there. Tomorrow, if I introduce a new product, I don't have to go and retrain the model. I just put the corpus there and it can pull up. So you must have heard about many of these patterns, right, where basically you have a corpus, you have an LLM, you're basically, pulling it from the corpus and creating the natural language through the LLM, right? So that is one model which at least I have seen more and more that people, in fact, I think AWS now even has a pattern on their platform, right, of exactly the retrieval augmentation with an LLM.
All right, thanks.
Did that answer your question?
Yeah, it did, sir. Thanks.
Wow, so many questions. Nobody want to eat.
So nice talk, and this question is more pertinent to what you're doing with your organization, like about automating tasks for teachers. So there are a lot of tasks or a lot of pain points which teachers go through, which are like hidden in plain sight kind of problems, but not solved for. So for example, like I was doing this study for a client of mine in consumer research. So one of the teachers I spoke to was like, I have to collect student reports from subject teachers. I'm a class teacher. And the subject teacher's English is not good. So I have to solve for, yeah. So, these kind of issues, like I have to solve for problems which are not solved for by the, intellectual models of the world. So are you actually, taking feedback from the cohort, which is actually the beneficiary of your product? And are you then retracing that back to solutions which may or may not be sophisticated in description, but far more pertinent than
absolutely
going back to your D to N ratio?
Yeah, that's a very good point, right? I mean, so one is that we believe that we should not do LLM just because it's fashionable, right? And as you said, right, it's much more important that we solve the problem rather than whether I use the an LLM for it, or it could be just simply rule based, right? And what we do is the way we work is that we actually, so we have in our company we are about 120 people, we have about 10 in-house teachers, right, who have taught for like 20-30 years. And then we have some of our the schools and the school districts. So we are mostly focused right now in US and UK, right? So we have our champion teachers whom we constantly spend time with to actually understand, right? Whenever we build something, we go to the teachers and tell them, do you think this is useful? Is this even what are your pain points, right? All of that. So as you said, right, there's a very similar workflow that we know that the teachers, as you said, right, it's not really like day to day, but for example, just report card generation, right? The fact that the teacher has to write a short summary of the child, right, of what progress they made for the last whatever, right, for the last month or whatever, and then put the grades with it and send out an email is a workflow that takes a lot of time for the teacher, right? So what we are trying to see is that how LLMs can possibly automate that, right? Whereas here, the automation and anything, right, in education, there's nothing that happens without the teacher. Teacher is always in the loop because it's absolutely important that anything that is passed through, if there's a report card that's generated, if there's a particular essay that has been graded, all of that, or a question assessment that is generated, all of that has to go through the approval of the teacher. It's just that we augment the teacher to say we make it a verification job for the teacher as opposed to a creation job. That's how we are looking at all these aspects of generative AI.
You said that you have a panel of teachers, right? 10 teachers. So you said that you have a panel of 10 teachers. So this is like a Delphi sort of a group.
Yes.
So
exactly.
How have you selected those teachers? Is it purely on experience, or is it also taking into account some kind of cultural diversity? Because you said US, right? So some Hispanic kind of teachers and so on.
Absolutely, that's again a very good question. So yes, we consider teachers who have worked in school districts that are not the best well-off, right? I mean, so across US there are very well-resourced school districts, there are less well-resourced school districts, and so on. So we have teachers. We have selected that diversity, right? And also the teachers whom we work with, we ensure that we have, people, as you said, right? I mean, Hispanic background, right? Teachers who have worked in school districts which were a little more challenging, right? And so on. So we try to ensure that diversity. That's a very good point.
We have a question from online.
Yeah, exactly. I wanted to say, guys, that as you started, Prasenjit, that you don't want to keep people in between coffee, So you can do two things together, actually, drink coffee and ask Prasenjit, I think. So we'll take one question from online, and then I will let you all go, chat, connect, ask all the questions, and be pretty much enjoying also the food and the catering, which is, I guess, hot, prepared, and nice. So the last question, to not keep you from refreshing yourself a little bit. So there is Suresh asking, do large language models, I guess, built for domain data by companies have advantage in front of the small models, since these big models can do a lot of tasks? Because from his perspective as a side comment, that one and few short learning are something that large language models can do without even being trained for that. So I guess he has some doubts with domain specificity.
Yeah, no, that's a good question. That's exactly the point I was trying to make, right? That even though we see this large, and I would call large is now relative, right? Let's call it massive, right? This size model, right? Hundreds of billions and trillion parameter models, right? The fact that they are able to do many of these tasks zero shot doesn't necessarily mean, first, right, that they are good for any tasks, right? And the second is that a smaller model may not be good at that task, right? And that's what those two examples that I put there, and there are many more examples where it has been shown that the smaller model trained on a very specific corpus perform much better than a larger model, right? So Suresh, to your point, the point I was making here is that you can do as well or even better with a smaller model as opposed to a larger model, where you obviously can do well, but not necessarily better when you talk about very specific domains. I hope that answered the question.
Thank you very much.
And thank you very much. Third time. So I would say that we will conclude it. If you will have a feeling, and I guess you will do, as you're really passionate about your talk as a Monojit also, and me, you can answer following questions in the venue. And the last thing before, like, starting networking and closing our meetup in the just like warm atmosphere of talking and eating, guys, please leave us a feedback. And we really appreciate it. We're trying to get better. We're from people to people, from engineers to engineers. And also all the videos, if you missed something, if you did not understand something, if you would like to rewatch some moments or rewatch some questions, if you left us your mail, we're going to send them. We'll have the recordings and everything that you would like to have. And Valia, your last words. She said me that she has a stage fright, by the way, so be nice.
So I have, the nice part, and thank you very much for all your questions. And I just want to give some t-shirts for the people who was asking. I actually didn't see the guy who was asking Zhenya first questions for the first talk, but I would love to give it for you, because you actually was asking Monojit like a lot of questions, and actually like proper one. So this is for you. Just come for me. Yes. Thank you very much. And also, I would love to give you a t-shirt, because you are the first person, like the closest one probably for me, that actually asked a question for the third topic. So thank you very much, guys. And so you are invited to have some food. Today is Friday evening, so just like for the networking, we actually was working a little bit to give your badges, so we're going to know from which companies the people are, so to understand and what kind of experience you can share. So we can be here till 8 on the venue. So enjoy, and thank you very much for your participation. Thank you.
One last thing to do. Just please take pictures inside the reactor itself. As this is a research facility, it's restricted outside taking the pictures. I recommend you to take pictures inside the reactor itself. Thank you.
A group pic. No. No. Entire audience.
Oh,
I'm gonna do in the when they're gonna talk now.
it's not allowed. She just literally just